In this lesson, we're going to solve special types of linear systems. All right, so remember so far in this chapter, we have learned three methods to solving systems. The first method was by graphing, the second was with substitution, and the third method was with elimination. Let's go ahead and take a look at what happens when there are no solutions when you use each of the methods. So for number one, we're going to solve this using the graphing method. So I have y is equal to 3x plus 4. Remember, our slope is 3 and our y-intercept is 4. So I'm going to plot the first point on the y-intercept, which is 4. And then from there, I'm going to go up 3 over 1 because I have a slope of 3. So up 1, 2, 3 over 1. All right, to make sure I get a nice straight line, I'm going to go down 3 and negative 1 here. That just gives me more points to be able to get a nice straight line. All right, so we've got the first line. So now let's graph the second line, which is y is equal to 3x minus 2. So this one we're starting on the negative 2, and then from there we're going up 3 over 1. Let's do it one more time. So now we'll try to draw a straight line. So now let's think about what we know about these two lines. It appears that these two lines are parallel, and we know that parallel lines never touch. And we know that they're parallel here in these two equations because remember we had learned in a previous chapter that parallel lines have the same slope, and both of these lines have a slope of 3. Now remember what we know about solving a system. In a linear system, the solution is the point at which the two lines are going to intersect. Well, because these lines are parallel, these two lines are never going to intersect. So the solution here, it is a no solution. And you know that when we put this in for our assignment, that we use that then DNE. All right, for question number 2, we're going to solve this by using the substitution method. And since we've already solved for y, we're going to take what we have for y and we're going to substitute it in where we see the y. We're going to take that entire expression. So I would have negative 6x plus 2 times 3x minus 2 is equal to then 8. So all I did is I plugged in that expression for that y. So now let's go ahead and simplify and solve. So the first thing I'd want to do is I would want to distribute. So I've got my negative 6x. I'm going to have plus 6x minus 4 is equal to 8. All right, so I want you to notice what's happening with these x's. I have a negative 6x plus a 6x. Both of my variables have canceled out here, and I have 0 x's. And remember when this would happen in the past, we would then take down what we have left, which is the negative 4 and our 8. And here we have to ask ourselves, is negative 4 equal to 8? Well, it's not equal to, they're not equal. So this here then is a no solution. And we would put this in as a DNE. All right, so question number 3, let's solve this one by using elimination. So I have a 6x minus 2y is equal to 8, and I have a 6x minus 2y is equal to negative 4. Well, in order to get something to eliminate, I'm going to take the opposite of everything on the bottom. So I have a positive 6 and a negative 6. So if I take the opposite of positive, I have negative. The opposite of negative, I have positive. And then the opposite of negative, I have positive again. Now let's go ahead and add these two together. So I have 6x plus a negative 6x. Well, notice how that one's going to cancel out. And I have a negative 2y and a positive 2y. Well, that cancels out as well. What I need you to do is you need to bring down a 0 because there's nothing left over there on that left side of the equation. And then I'm going to look to the right side of the equation, and I have now 12. Well, is 0 equal to 12? It's not. And so that, again, is a no solution or DNE. All right, example number 2, how do I identify systems with infinitely many solutions? So the first one, we're going to solve this by graphing. And the first equation we have already had, it's already solved for y. So let's start, and the y-intercept is 2, so we'll start on the 2. And from there, we're going to do our positive 1/2 slope, which means we're going to go up 1 over 2. I'm going to just do it one more time so I can make sure I get a nice straight line. Well, not super straight, but it'll do. All right, so for our second equation, we have x minus 2y is equal to -4. Well, we could either solve for y, or we could graph this by using the intercepts. I'm going to solve it for y because I want you to look at see what you notice about the equation after we solve for y. So we have x minus 2y is equal to -4. And so we're going to minus the x. And then we have -2y is equal to -4 minus x. Well, I have to divide by -2. And so we're going to have y is equal to 2, and then 2 negatives make a positive, so we're going to have plus 1 all over 2x. So when I would go to graph this one, I would come on my 2, and I would go up 1 over 2. Notice how these two equations are the same. And so they were just in two different forms. One was in slope-intercept form and one was in standard form. But they have got the same slope and they have the same y-intercept. And when this happens, then one line is on top of the other line. And so in every case, in every solution that one line has, the other line also has. And so this one is an infinitely many solutions. All right, so for number 2, we have the same two equations, but this one, let's go ahead and solve it by using the substitution method. Notice how we've solved for one of the variables. And so I'm going to take, we're saying y is equal to 1/2 x plus 2. So where I see this y, I'm going to plug it into that equation. So I have x minus 2 times 1/2 x plus 2. And then we're going to say that that is equal to -4. All right, so now let's go ahead and we have to distribute. And we have x minus then -2 times 1/2 x gives us just -1x. And then we're going to have minus 4 is equal to -4. All right, we need to then simplify before we can solve. And notice how the 1x and the minus 1x, how those two cancel out. And I'm left with a -4 is equal to -4. Well, is -4 equal to -4? It is. And so we're going to call this then, remember we call that then infinitely many solutions. And now for number 3, let's go ahead and solve this one by using the elimination method. If I'm going to eliminate, I need to make sure that all of the variables are lined up. I also need to make sure that one's going to cancel out, or at least one variable will cancel out. So I'm going to multiply, I'm going to go for these y's. I'm going to multiply everything by a -2 so that I end up with a positive 2y. So -2 times 1/2 is going to give me a -1x. Negative times a negative gives us a positive. And a negative times a negative, we're going to have a positive 4 here. Now I'll just rewrite my equation, this one right here. I'm just rewriting this one. All right, so when we look to eliminate then, I'm going to notice that a positive 1 and a -1 cancel out, give me 0. I'm noticing that a 2y and a -2y are also going to cancel out and give me 0. So I'm going to put 0 on this side of the equation. And then I have 4 minus 4 also gives a 0, so we have to put a 0 over here. And because 0 is equal to 0, we're going to call this then, again, it's infinitely many solutions. So how do I tell if a system has one solution, no solution, or infinitely many solutions without actually solving the system? So remember back when we found the one solution that we had said that it's where the two lines intersect on the graph. So on a graph, when we had graphed the ones with a one solution, they came together at a point. And these are all the ones that we did in the first sections of this chapter. And then what we knew about the slopes and the y-intercepts is that we had different slopes. And the y-intercepts really aren't going to matter there. It didn't matter which y-intercept you had, but the fact that they had different slopes is how each of the lines went into different directions, and then eventually they would then come together at one point, and that was the solution. Now we learned that on a graph, if you've got parallel lines, that means that they're never going to touch. And so they have same slope. So they have the same slopes, and they have to have the different y-intercepts because that's what makes them then further apart from each other. So different All right. Now let's think then what the infinitely many solutions look like. Well, remember the infinitely many that you had one line on top of the other line, so it really just looked like kind of one line. For these, they had the same slopes, and they had the same y-intercepts. So in this lesson, we took a look at what it looks like when we have no solution and infinitely many solutions in solving a system.